Good evening. Welcome to our international speaker series. My name is Angela Zhang. I'm the director of the Philip K. Wang Center for Chinese Law. Today, I'm going to invite the author, Chris Miller, to give a book talk on his super exciting new book, The Chip War, The Fight for the World's Most Critical Technology. And you probably have read in the news, this book has been a sensation since it came out, and it's on an extremely timely topic that is of great interest to our audience. Our talk has attracted an unprecedented number of audience today. So before I give the floor to Chris, let me give a very brief introduction of our speakers. So we have author Chris Miller with us. He is an associate professor of international history at the Fletcher School of Law and Diplomacy at Tufts University. He is also a Jeane Kirkpatrick Visiting Fellow at the American Enterprise Institute and the Eurasia Director at the Foreign Policy Research Institute. His research focuses on technology, geopolitics, economics, international affairs, and Russia. And I'm also super excited to introduce the discussant for our book talk tonight. It's Paul Trilio. He is a Senior Vice President for China and Technology Policy Lead at ASG. Paul is a leading expert in this area, and I am so glad he can join us tonight. He advises clients in technology, financial services, and other sectors as they navigate complex political and regulatory matters in China and around the world. Although Paul looks very young, he has a lot of experience. He was most recently founder, practice head, and managing director of the Geotechnology Practice and Eurasia Group. And previously, he spent more than 25 years in senior positions in the US government, analyzing China's rise as a technology power and advising senior policymakers on a broad range of tech-related issues. So I really cannot think of a better person to comment on the book today. So without further ado, let me give the floor to Chris.
Thank you very much, Angela, for the invitation and the introduction. And thanks also to Paul for agreeing to join this conversation. I'd love to share some thoughts with you on my book, Chip War, but perhaps before I begin that, a bit of background as to how it is that I came to write this book. As Angela mentioned, my background is in Russian studies, and my previous 3 books have been on the history of Russian economics and politics, which most of you might not think would be a natural background for writing a book on semiconductors and their role in international affairs. About 5 years ago, when I started this project, I was initially planning to write a book about missile technology during the Cold War and the US and the Soviet missile race during the 1950s, 60s, and 70s. And the more I learned about missile technology, the more I came to realize that the interesting parts of developing missiles was not the rocket engines nor the metallurgy involved, although there's some complicated metallurgy as you get to more sophisticated missile types, but the guidance computers inside of missiles were the most fascinating part. And the development of advanced guidance computers was one of the greatest challenges, not only of the Cold War or the arms race, but of all of science and engineering over the past century or so. And the guidance computers that were involved in or necessary for missile development in the 1950s and 60s not only were important for missiles themselves, but it gave birth to the computing power that we take for granted today. The first major order for semiconductors in the early 1960s was for the guidance computer in the Apollo spacecraft, which guided the first mission to the moon. The second major order for semiconductors after they were invented was for the guidance computer on the Minuteman II intercontinental ballistic missile, which was designed to carry nuclear warheads from the United States to targets in the Soviet Union. So there's been a direct and deep interconnection between military demands for miniaturized computing power and the technology that's inside of all of our smartphones and PCs. And although today we think about chips primarily in the context of consumer devices, the reality is that there's been a deep interconnection between the production of military power, the demands of militaries around the world, and advances in computing. And what I'd like to suggest to you, and this is what I realized as I began researching this book, Chip War, is that in fact, military concerns, defense concerns, security issues have been central to the chip industry over the past 60 years. obviously not the only factor. Business models, economic issues, consumer demands have been hugely important as well. But it struck me when researching this book that there was a lot more discussion of the economic imperatives of the consumer demands than there was of the interrelationship between military concerns and the electronics industry and the computing industry as well. And so the main argument of chip war is, in fact, that there are multiple wars or battles going on within the industry, battles between companies, battles between countries, but also battles between militaries for the ability to secure access to the most advanced technologies. What I'd like to suggest to start is that although today we associate chips with things like smartphones or data centers, and we rely on chips for almost everything in our daily lives, from cars to dishwashers to microwave ovens. In fact, as I mentioned, the origins of chips is in missile guidance systems. And you can't understand how the chip industry has developed without taking into account its deep interrelationship with the military, and especially the US military, which has funded many of the key advances in chip technology. We wouldn't have had a shrinking of computing power and a reduction of the demands for energy usage in computing power unless there had been such a need for smaller, more power efficient computers inside of missiles. And if you think back to what a computer looked like in the late 1940s, a computer was the size of a room, required vacuum tubes, light bulb-like devices that turned on and off to function, and consumed an enormous amount of power. And so the most advanced computer in 1945, for example, the ENIAC computer at the University of Pennsylvania, had only a tiny fraction of the computing power in your smartphone, and it would have been completely incapable of sending a missile anywhere because it was simply too big to put on a missile. And so the key challenge over the past several decades has been miniaturizing computing power so that now we have computing inside of our iPhones, for example, that is many times more powerful than the computer that guided, for example, the Apollo spacecraft to the moon. And that is largely driven by defense demands and also defense R&D dollars, which have shaped the direction of the industry. Today, just like in the early decades of the Cold War, military systems are fundamentally reliant on computing power. Even relatively old defense systems like the Javelin anti-tank missile pictured here, which has played a big role in the Russia-Ukraine war over the past several months, are fundamentally reliant on semiconductors. Each Javelin missile, for example, has over 200 semiconductors inside, and this is an old technology, first designed several decades ago, and newer technologies are even more dependent on advanced computing. If you look at how defense planners in the US or in other countries envision the future of warfare, they envision battlefields that are involving more computing distributed across different systems, more secure communications, more need for intelligence and surveillance, more need for processing power distributed across the battlefield, and all of that means computing power. All of that requires semiconductors, whether it's semiconductors that are high power processors, semiconductors that are sophisticated memory chips, or complicated digital signals processing semiconductors. The wars of the future will be even more reliant on semiconductors than today. And this is something that certainly in the US defense planners are thinking about, but also in other countries. In China, for example, there's tremendous amounts of discussion about the application of artificial intelligence to military systems, or autonomy to military systems. And you can't have an autonomous military system unless you've got a ton of processing power, very large amounts of memory, and a lot of signals processing in that system. And all of that requires advanced semiconductors to work. So wherever you look around the world, you'll find that militaries are planning, and in many cases designing, in some cases even rolling out systems that are far more dependent on semiconductors than ever before, because the advanced computing on which they will rely is only possible thanks to semiconductors. So as a result of this, the struggle for the most prominent position in the semiconductor industry is not only driven by firms. It's not only driven by products. It's also increasingly driven by security and military demands. And this is a shift compared to the past couple of decades, although in some ways it's a return to the origins of the industry. Since the 1990s or so, the chip industry has been largely able to ignore security and geopolitical questions, in large part because most of the industry was focused either in the United States or in a small number of countries that the US felt were close partners or allies. South Korea, for example, Taiwan, Japan, and the Netherlands. But as tensions between the US and China have grown, both Washington and Beijing have placed a lot more emphasis on trying to increase their influence in semiconductor supply chains and domesticate, where possible, some of the technology and the production capacity that they believe they need. So in the United States, there's been a couple of major moves in the past several months. First, Congress has passed the CHIPS and Science Act, which will devote several tens of billions of dollars to incentives for manufacturing advanced chips, primarily in the United States, as well as a lot of new money towards R&D in the chip sector. In addition, DARPA, the Defense Department's Advanced Projects Research Agency, several years ago launched an electronics resurgence initiative designed, again, just like in the early days of the chip industry, to put more money into advanced chip making and chip design technologies, specifically to enable military systems. And then finally, as I think Paul will probably discuss later on, the Commerce Department has rolled out a series of pretty dramatic controls on the export of chip making equipment and certain types of chips to China. So there's a lot of movement in the US when it comes to the chip industry, largely driven by security and defense concerns. That's the big shift that's happened over the past couple of years. And similarly, in Beijing, there's more concern than ever before about semiconductor supply chains. China spends as much money importing semiconductors each year than it does importing oil. And policymakers in Beijing realize this is a vulnerability and have been trying for some time to address it. Since around 2014, the Chinese government has flagged this as a major policy priority, and it's launched a series of different industrial policy initiatives designed to put substantial sums of money into the chip industry. And this takes place both at the national level, where there's the big fund for integrated circuit development, but also at the provincial and local level, where many provinces and local governments also have various initiatives to support the semiconductor industry. And so estimates of the size of the amount of money flowing from government and government-backed sources into the semiconductor industry in China are dramatic. One of the largest industrial policy programs, according to Barry Naughton, one of the experts on the subject, in the recent history of the Chinese government. So there's a clear priority in China around this issue, and it's easy to understand why, because today chip making in China is largely reliant on the importation of software, of machine tools, and also of raw materials like refined chemicals from countries that, to some extent at least, are geopolitical rivals of China. That includes the United States, Japan, Korea, and Taiwan as well. And so as these countries have, to varying degrees, tightened restrictions on what types of chips they're able or willing to sell to China and what types of chip making equipment they're able or willing to sell to China, China has faced a greater need to find alternative and ideally domestic sources of supply. And so a huge wave of subsidies into China's chip industry is partly driven by this desire to have domestic sources in case international sources of tools and equipment get cut off, or in some cases they already have been. So both from Beijing and from Washington, there's been a big shift in terms of the concerns about security taking a center stage in semiconductor supply chains, rather than concerns about economic efficiency. Because of course, none of the government programs to intervene in supply chains are economically efficient. Today, the chip industry made possible its immense ability to produce lots of computing power at low prices, thanks in no small part to a very complex international supply chain. And so long as governments are trying to slowly change the shape of that supply chain or pick it apart, that will create more economic efficiency, higher costs as well. But governments are deciding that that's a price they're willing to pay as they focus more on security than they have in the past. And it's worth noting, I think, that although the US and China are in some ways the two players that have seen the biggest shift in their approach towards semiconductor supply chains, they're not alone. The Japanese government, for example, imposed a set of export controls on the supply of certain chemicals to South Korea several years ago. Russia earlier this year cut off the export of certain noble gases that are used in semiconductor production with the aim of causing supply chain issues. So you can look at many countries that have a role in the semiconductor supply chain, and almost all of them are emphasizing security concerns far more than they would have several years ago. So how does this play out in practice? Well, if you look at the semiconductor supply chain today, what you'll find is that the United States is still the most important player when it comes to its position in the value chain across the different steps of the semiconductor production process, in designing chips and the production of software tools that are needed to design chips, and the production of the tools that are used to manufacture chips. All of these are places where the United States maintains a major role. Other big players are South Korea, Japan, and Taiwan as well. And because the chip industry is defined by a series of choke points, where a small number of companies, and in some cases only a single company, play a critical role in the supply chain, this is an industry in which governments have found that it's comparatively easy to cut off their adversaries because alternative sources of supply are limited and costly. So, for example, when you look at the production of machine tools needed to make chips, the Netherlands company ASML has a 100% market share on the production of extreme ultraviolet lithography machines, without which it's simply impossible to make an advanced chip. So with choke points like that, where there's market shares of 100% in certain critical tools, it's perhaps not surprising that we're seeing governments try to take advantage of those choke points. And when you look at design, software tools, chemicals, fabrication tools, what you'll find is that in almost every part of the supply chain, there are choke points where a handful of firms, or in some cases a single firm, play really fundamental roles in the market. And so long as these choke points exist, governments will feel some compulsion to use them. And we're certainly seeing that play out in a much bigger way in recent years. However, the Chinese government is, of course, spending very heavily, as I mentioned previously, with the aim of trying to reduce its reliance on some of these choke points, whether it comes to chemicals, fabrication tools, software tools, or chip design themselves. And by any estimate, China's role in the chip supply chain is going to grow over the coming decade, though it's likely to be the case that the expansion of China's role is primarily in lower technology chips rather than the most cutting edge. But in particular, in the process of making chips, manufacturing chips, most estimates have China's market share growing pretty substantially over the coming decade. But the key question, I think, is to what extent the technological tensions that we've seen over the past several years intensify, which they could well do. We've seen tech tensions over Huawei, for example, over the export of fabrication tools from the US to China, and export controls that not only prevent the transfer of US technology to China, but also that prevent other firms like Taiwan's TSMC or South Korea's Samsung from using US produced tools to create chips that are then sent to China. So there's an extraterritorial facet to these export controls as well. And the impact is already becoming visible on the semiconductor supply chain. The idea that any country can, on its own, produce the most advanced chips, I think still remains a fantasy. But the reality is supply chains are shifting under the weight of this new political pressure. First, Taiwan's TSMC is slowly beginning to diversify its production base, not in a dramatic fashion, but nevertheless, it's opening new facilities in Arizona and Japan, and may also open facilities in Singapore and in Europe down the road. This is a major change for TSMC, which previously has not had any substantial production facilities outside of Taiwan or China. Second, China's been cut off from accessing many of the most advanced machine tools, in particular, most importantly, probably the extreme ultraviolet lithography tools that I mentioned earlier, which it's impossible now for Chinese firms to buy. Third, the US, via new regulations, appears to be dead set on stopping China from transitioning to new and more advanced transistor architectures, which will allow the further shrinkage of transistors and as a result, more advanced computing power. Fourth, China continues to put money into its build out of fabrication capacity, especially in less advanced logic chips. And we should expect this to have a big impact, I think, on the market for chips globally and on the profitability of firms competing in this segment of the market. And then finally, most interestingly, governments around the world are pouring money into capital investment, whether it's China or the US, both of which I mentioned, also Japan, Europe planning 50 billion euros of new expenditure, and then Taiwan, Korea, Singapore, other players in East Asia as well. Almost every major government is putting new money into fabrication, and a lot of this money is going to go towards lagging edge fabrication, risking substantial overcapacity, but governments are doing it anyway, in no small part because they think the margin of security this provides is worth the cost. So to sum up, we're seeing a dramatic shift in the semiconductor industry, away from an industry in which cost efficiency and technological advances were the two driving factors over the past several decades, but a return in some ways to the earliest days of the industry when it was the demands of defense production and concerns about military technology that were key factors in explaining how the chip industry first emerged and how it developed over time. And I think we should expect this dynamic to continue, because as long as the military balance is in question, and indeed today the military balance in East Asia is shifting as dramatically as it has at any point in the past several decades, I think it's only natural and to be expected that governments will focus on technologies where they think they might be able to achieve a military edge. And when you look at how defense planners are thinking about advanced military systems, computing power, signals processing, communications abilities are at the center of all of these systems. And for all of that, they will be reliant on semiconductors. So to sum up, we're seeing a chip war, not only in the way we've seen it in the past, a battle between companies or products or types of technologies, but also a return to defense and security concerns playing a central role in the chip industry. And that will have a dramatic impact, I think, on the US-China relationship and also the structure of semiconductor supply chains across the Asia-Pacific region. So I'll wrap up there, but I'm looking forward to hearing Paul's comments and then questions from the audience.
Thank you so much, Chris. And I would like now to invite Paul to give his feedback and also remind the audience that you can send your questions through the Q&A box, and we will talk about that after Paul gives his comment. Paul, please.
Angela and Chris, great, a great summary of the book. And I think one of the things that comes through is this sort of civil-military fusion, and the importance of semiconductors, of course, in the military domain, which of course is exactly the justification the U.S. is using to restrict various types of semiconductors and equipment for China. So it's an interesting dynamic here. I think Chris is absolutely right about the role of military funding and the priorities in developing sort of semiconductor manufacturing over time. But I think it's important to note, too, that it's only because now the economies of scale provided by consumer uses and applications of semiconductors that have allowed this sort of the innovation to really continue, Moore's Law to continue, which Chris addresses in the book, I think, very well. And so this TSMC, for example, the leading foundry in the world, has to invest $40 billion in a new fab that will make sense economically. They have to have a huge client base over which to amortize the cost of that facility and R&D, et cetera. And the military portion of that in terms of clients is very, very, very small. But of course, it's important. And it's, as Chris notes, it's certainly come back to being a more important issue, which we can talk a bit about here in terms of, for example, the recent export controls. So I think though that the war meme, the chip war meme, and again, I'm sort of guilty of that. I used the hashtag US-China Tech Cold War back in 2018, I think, for the first time, which a lot of people have picked up. In the semiconductor industry, it's tricky. I think you have to be careful because it has been, well, there's been a lot of competition, and Chris, I think, does a great job of laying that out, the sort of history there. The evolution over the last decade, arguably, has been, one of more, there's a lot of competition among companies. But there's a lot of collaboration too, and it's a very collaborative global industry. And so, as Chris notes, now as we sort of governments re-inject themselves into the picture, the war is more. You have the sort of the great powers and U.S., China, et cetera, and then there's the industry, right? So I think it's always important to keep in mind the sort of the difference between the government and its aspirations, whether that's China or the U.S., and the industry, and how those aspirations redound on the industry. I thought Chris did a great job in the book of highlighting, some of the particular the people and the history, the key figures in the industry. But what was really interesting was there was sort of deja vu all over again. So, for example, he notes that Jerry Sanders, the CEO of AMD, in Chapter 16, at war with Japan, that he thought that the Japanese had 4 unfair advantages. They benefit from IP theft, protected markets, government subsidies, and cheap capital. Those are exactly the criticisms of China by the U.S. now. And so it's interesting to see sort of this come around full circle. And then I think it's fascinating that he notes that Akio Morita, the Japanese, the head of Sony, pointed out the problems with the U.S. Too busy creating lawyers instead of engineers, too focused on this year's profit, not enough training or motivation for shop floor employees. Exactly the criticisms that Taiwan and Morris Chang and others at TSMC are leveling against the U.S. In terms of the CHIPS Act, whether the U.S. is really firmly committed to long-term manufacturing, which is very difficult and requires a certain culture and sort of business approach, and that some think the U.S. doesn't have, and we can talk about that. So I think what I focused on in the book, I think were 2 things: was the China piece and the Taiwan piece, which I think are the Taiwan aspect of this whole thing. I think is really the most important part of this. And then the other thing that I think is important, I think Chris does a good job of bringing this out, is the importance of U.S. company dominance of the tools. The tools to make semiconductors. That's really where the new export control regulations, for example, are particularly important. And so I think that can't be stressed enough, in some sense, that the dominance of U.S. companies like Applied Materials, Lam, KLA Tencor, and the metrology side, and then the EDA tool players, the electronic design automation tools, which are closely coupled with the manufacturing process. And U.S. companies like Cadence and Synopsys and Mentor, which is a Siemens company, but really has a lot of U.S. IP there. That's a really critical piece of this. And so, for example, in China, China has sought self-reliance in some areas, or sought to reduce dependence. Maybe a better way is to say reduce dependence on foreign technology. But when it comes to things like EDA tools, trying to reinvent a whole ecosystem around EDA tools really doesn't make sense. To some degree, because you have these leading companies that have very sophisticated tools and are very tied into the foundries. And so why would you, given a choice, why would you not just use those tools and use them to design your semiconductors and manufacture them somewhere, as the sort of fabless model, which Chris, I think, does a good job of outlining in the book. That's where the industry really is, right? So with the dominance of a company like TSMC or other foundries like Samsung to some degree, and now Intel getting into the foundry business, that fabless design, chip design model is really what's made the industry go forward, because TSMC has focused so much on the manufacturing side of it and becoming very good at that. And so the Chinese companies, of course, naturally have gone down that road too, because that's sort of the industry standard. And so I think it's important that in doing that, of course, those Chinese companies, like other companies, end up being dependent on U.S. technology, and that has implications when the U.S. chooses to use those choke points, as Chris has noted. So China, I think, is really important to focus on here. Quickly. So China, I think the section on China's industry is good, but I think there's some things that maybe could have been brought out a little bit more. And again, I've been looking at this for way too long, so I have a certain bias here. I think subsidies, for example, that Chris noted, that government part of it, that's not really a very good long-term business model, right? And neither is IP theft. And semiconductors sort of illustrate this, right? So despite nearly a decade in China, for example, of basically limitless subsidies, China has produced really only one firm YMTC that's capable of competing at anywhere near the cutting edge or globally, right? And SMIC to some degree, but it was not as heavily subsidized until recently. So it's not surprising that the Chinese government would pursue subsidies because they were way behind, and many governments pursue subsidies. But China's approach could never really, for example, that approach would not be able to compete or produce a Chinese version of TSMC, for example, because that's driven by market forces and development of trust and overall the trust in TSMC and the IP protection, et cetera. So China's approach of government sort of top-down sort of subsidies, which they're going to probably do more of in the wake of some of the recent export controls, is really sort of counterintuitive to the industry, because the industry globally is very market-driven, and so the more government spending and more government subsidies is not necessarily going to produce outcomes that are produce competitive companies and up China's position in the global semiconductor sort of division of labor. The National IC Fund, which Chris mentioned, was established in 2014. Tens of billions of dollars, not all of which has been invested. And of course, this year there's a huge investigation of the National IC Fund for corruption, which suggests too that the Chinese government hasn't been happy with the results produced by the National IC Fund. And at the same time, we also had Made in China 2025, and as part of the Made in China 2025 sort of series of documents, there was a document produced by the Chinese Academy of Engineering that included specific domestic targets for production. So 70% of domestic semiconductors by 2025. Now that was just done by some very serious engineers at CAE, but completely divorced from the reality of the market. And so all of those targets that are in that CAE document associated with Made in China 2025 are wildly unrealistic. And by 2025, China will not be producing anywhere near any of those targets. But those targets are often cited as an example of how China wants to dominate the semiconductor industry. But really, that again, government sort of aspirations and government policy preferences need to be separated from the sort of reality of the industry, which is very, very market driven. And then I think also Chinese companies were really far behind in 2014. And so that this type of roadmap was pretty unrealistic. And they remain pretty far behind, depending on the subsector you're talking about, because funding is really only one factor here in the industry. It can make a difference in some places, but not across a complex supply chain with dozens of technologies and the competition innovating faster. I was talking to a CEO of a really innovative US company, Marvell, and he said, look, I have thousands of engineers, great engineers, I have technology, I have intellectual property, and I can only move the needle a little bit in my market niche. So again, for China to try to reduce dependence and create dominance in any of these sectors is a huge challenge. And again, China's ambitions here the government and the industry are on different wavelengths. I'm on a track 2 dialogue with China where we talk about semiconductors, among other things. And one of the last dialogues we had Wei Xiaojun, who's at Tsinghua University, and he briefs the China's Politburo Standing Committee when they do study sessions on technology, which they do fairly often. So he briefs Xi Jinping on technology, and he admits that everybody in the Chinese industry who understands this global division of labor recognizes that self-reliance is a possible goal, but they're under a lot of pressure from the government. They're intense pressure to reduce dependence, and U.S. actions like these export controls that we'll get to give China no choice but to pursue, sort of double down on this self-reliance meme. And so you see a lot of that even in the last year coming from the senior Chinese leadership. But again, as I noted, given their preferences, Chinese industry and Chinese companies that were going to do chipless fab design would reach for the best available tools, just like anybody in the world would do, and they wouldn't seek to pursue alternative development. But again, the geopolitical landscape is very complicated now, and so the Chinese industry is under a lot of pressure to develop alternatives almost in every area to U.S. technology. And then I think Taiwan is really important. Chris has a good chapter on Taiwan, but I think it really is the sort of crux of the issue going forward. As we look forward, the status of Taiwan sort of looms large the largest really issue in the industry, right? Because as the U.S. woke up to the danger of this dependence on Taiwan and TSMC and launched the CHIPS Act, the discussion started in 2020, around 2020, and began luring companies like TSMC and Samsung and others, Intel, to build new fabs in the U.S. This was just at the time that the U.S. and Taiwan U.S. and China relationship was becoming much more tense. Technology competition at the center, as Secretary Blinken noted in his May speech, and so I think Taiwan then now has become sort of the focal point of all this, and Taiwan is dragged into this in many levels because of those extraterritorial export controls that Chris mentioned. So while the CHIPS Act was designed to reshore advanced manufacturing, the question there is going to be how much is enough. TSMC, given its druthers, would probably not want to build a fab in the U.S. because they're very good at building incremental new fabs in Taiwan. They understand the market conditions, they understand the government support, and the culture, importantly, right? And so they're very skeptical about the U.S. and its long-term commitment to manufacturing and to those subsidies. The CHIPS Act runs out in 2026, for example. And so will the U.S. continue to fund advanced manufacturing beyond 2026? And then the question still is how much is enough. So some projections by 2030 suggest the U.S. could have 5 or 6 advanced fabs and some number of advanced packaging facilities. But the other pieces of the supply chain still not clear. Upstream, how much upstream and downstream capacity will be in the U.S. But there will be some reduction of that dependence on TSMC, but probably not all that much, right? Because that picture that Chris showed of that the Phoenix or the Arizona fab, they're going to start with 10,000 wafer starts per month there. TSMC in Taiwan is well over 1 million and moving north. So in terms of that facility putting a big dent in making a difference in terms of the geographic concentration in Taiwan, right? It's going to take some time. They will expand that fab, but it's not going to be anywhere near a significant reduction in that dependence for some time. So Taiwan, again, for the next 10 years is going to be central to the industry in a way that I think people now appreciate, but it's really hard to change that because these are 5 and 10-year horizons for companies to build fabs and to amortize the cost, et cetera, et cetera. So the other piece of this, though, then is that as this is all happening, there's a focus on Taiwan in the wake of particularly the Russia-Ukraine situation. People are sort of saying, well, China and Taiwan, is similar. I think that's a really bad analogy, frankly. I mean, I think Chris mentions it in the book, but I do not agree with the statement that Chris made in the book that what happened in Ukraine could not happen in Asia. I think the two situations are very different. And so I really disagree that with the sort of, a lot of people make this analogy, but again, I think that China and Xi are not Russia and Putin. And in fact, in contrast, you could say that Russia and Putin make Xi and the Chinese leadership seem very, very sane. It's inconceivable to me, for example, that Chinese leadership would threaten to use nuclear weapons here, right? So the issue is really under what circumstances the U.S. would accept a unification of China and Taiwan. And the U.S. policy right now is to continue, for example, relying on these 40-year-old documents that say that nothing has changed, that the U.S. still supports a one China policy, et cetera. But Beijing increasingly doesn't believe this, doesn't believe anything Biden or U.S. officials say on this. They're looking at actions, military sales, the Pelosi visit, the Indo-Pacific Economic Framework, and things like the CHIPS 4 Alliance, which includes Taiwan, and other statements by U.S. officials that essentially characterize Taiwan as part of the U.S. defensive perimeter in Asia, as a bulwark against China, which of course doesn't go down very well in Beijing. And then Congress in the U.S. is also weighing in, for example, with all sorts of crazy bills on Taiwan, which are, again, leading China to believe that the U.S. no longer supports unification, but is really pushing for Taiwan independence. And so then the question is, what's the, would the U.S. accept a peaceful reunification of Taiwan, for example? And this is where the semiconductor industry comes in, because I think the answer is now increasingly no, because of those facilities at TSMC, would U.S. officials accept China being in any position to control policy related to TSMC, for example? And particularly when you see the new export control package, which is essentially cutting off Chinese companies from using TSMC as a manufacturing base. So the problem is, how do you solve this problem, right? And preserve the unique nature of Taiwan's position and TSMC's position in the global semiconductor supply chain. And so my argument is that there needs to be some really creative thinking here to get beyond this idea of arming Taiwan to solve the China problem, right? I mean, I think again, those documents that were negotiated in the 70s, when China didn't have a military, Taiwan didn't have a semiconductor industry, and Taiwan didn't have such a vibrant democracy, don't really hold up right now. And I think that's the problem that we're facing going forward, is how to solve the Taiwan problem. And the semiconductor piece of it now is probably the most complicated piece, because TSMC, for example, couldn't survive for very long without complete contact with the outside world. Taiwan and TSMC in particular is in this real-time the position where upstream materials are floating in, wafers and materials and tools and services from the US and Japan and the Netherlands. And then semiconductors are being shipped out by air. So any kind of an air blockade, for example, on Taiwan would immediately disrupt the global semiconductor industry in a fundamental way. So I think that's an area where some creative thinking needs to happen here, because if we continue down this path of U.S.-China great power competition with Taiwan caught in the middle of it, and semiconductors sort of also part of the equation, I think the results here could be pretty serious. So finally, I think the issue of Chinese companies and the semiconductors is being framed, I think, in general in the wrong ways. Yes, the Chinese government, for example, has done subsidies, but all developed countries subsidize advanced manufacturing. So the question really going forward is, what are the good subsidies and what are the bad subsidies? The OECD did a really good study last year on this, and I think that's something that needs more discussion. But again, the approach of sort of cutting off China and Chinese companies from different pieces of the semiconductor supply chain, I think, rather than engaging in trade negotiations and discussing things like subsidies and trying to really solve those problems, I think is a really perilous path, which is going to have unintended consequences. These latest export controls, for example, which attempt to freeze China at different nodes in logic and memory, have really created chaos in the industry. And we have clients that have complained to me about them. They were dropped sort of suddenly, and those kinds of controls, I think, are going to have huge unintended consequences. They're going to have an impact on those U.S. tool makers and their profitability. I was on a call last week with Lam, and their earnings call, and they're looking at a $2 to $2.5 billion hit in 2023, depending on how those export controls are implemented. And other companies like NVIDIA, which is now restricted from selling its most advanced GPUs to China, also looking at similar levels of hit on this. So I think over the short term, there's going to be some big impact on both U.S. companies, of course, and Chinese companies. YMTC and SMIC, their leading foundry, are really in a difficult position now if the U.S. enforces all the restrictions, for example, on those semiconductor manufacturing tools that Chris mentioned. And then finally, again, this Taiwan problem, I think, is something that needs to be addressed in a more creative way, because further dragging Taiwan into this great power competition, I think, again, is dangerous. I've talked about unknown red lines, for example. So to the extent that these export controls cut off Chinese companies from being able to use TSMC, this started with Huawei in 2020, and now the latest controls add 28 more Chinese companies, all their leading AI companies, for example. Beijing is looking at this and saying, hey, Taiwan, we think Taiwan is part of China, but our leading tech companies can't use Taiwan as a manufacturing base. So we don't really know how Beijing will react to that. I think they will react to these latest export controls cautiously, but at some point strongly, because China, remember, controls some supply chains of its own and has some choke points of its own on things like rare earths magnets and EV battery supply chains. So I think, rather than getting into this sort of supply chain war, which this could evolve into, I think that that would be prudent for both sides to sort of step back from this. But the problem is the overarching U.S.-China relations are in such a parlous state that it's hard to see either side sort of backing down and taking a hard look at Taiwan and how to preserve sort of these global and pretty sensitive semiconductor supply chains that I think Chris really laid out well in his discussion. So it's certainly true that the military and that the driving force behind this are these military concerns that Chris mentioned. In the case of China, the use of GPUs, for example, advanced GPUs to do modeling for hypersonic glide vehicles that might come back and haunt the U.S. and Taiwan in the military contingency. But I think the bigger overarching issue should be trying to figure out a more creative way to preserve Taiwan as this and its position in the global supply chain, because the alternative is really of conflict would immediately disrupt not just the semiconductor industry, but the global economy, given the importance of Taiwan and all the ripple effects that would have if even one missile landed in Hsinchu Science Park, for example. So I think that's where we are now, and I think Chris's book really lays out in a fantastic way the history of the industry and then sort of how we got here. I think the going forward part, given the recent events and just sort of the coming to head of the bigger, great power competition in Taiwan, I think are really the sort of focal point of the industry going forward. We have clients who are asking us constantly for risk scenarios over Taiwan. And most of those are tech companies in the supply chains of the Taiwan companies, but also any company operating in Asia or in China is now worried about Taiwan. And that's sort of where we are. And I think the timing of this book couldn't be better because it really does lay out all the issues at stake here. And I think those risks I think are real that going forward. And I think we need people to be informed about how the industry works, which again, I think the book is great at doing that. But I think we need a new way to think about how the industry fits into great power competition, and in particular, the Taiwan issue. Let me stop there.
Thank you, Paul. I saw there's a couple of questions in the chat box already. And before we move on to the audience question, I actually you want to take advantage of the opportunity to ask you guys some questions myself. Feel free to jump in, either of the speaker. So my first question is really a layman's question. What I want to understand, a couple of years ago, I spoke to an industry expert in China, and then he told me, which I'm a little bit skeptical, that look, China can produce chips. In fact, China produces a lot of chips. And what we are lacking behind is the most cutting edge technology, like those smallest, tiniest chips that only TSMC can produce. But it looks like now we're in a very serious position. So the first thing I want to understand is what exactly is the technological gap between China and the US or other Western countries? Are we only talking about the size of the chip, or there's many other stuff that we're missing here?
Well, I think the first part of the answer to that question is to remember Moore's law, which has defined improvement in the semiconductor industry for the past half century. And so what Moore's law says, roughly speaking, is that the computing power produced by the most advanced chip doubles every 2 years. So if you're 2 years behind, you're only 50% as good. And if you're 10 years behind, you're really far behind. And so that's why being 1 or 2 or 3 generations in advance, more advanced than your competitors is a huge difference, because no one's going to buy a computer with a third or a quarter or a tenth of the computing power as what you can get in the cutting edge. And especially when it comes to data centers and artificial intelligence applications, having access to more computing power is absolutely critical. And so if we project forward in 10 years' time, if China is held constant in terms of the quality of advanced GPUs, and the rest of the world is not held constant and it's growing at an exponential rate, there'll be a large gap opened up. Now, as Paul mentioned, the tools needed to produce advanced chips are really complicated. You need software, you need materials, you need machine tools. And in most of these spheres, China's quite behind in terms of what's domestically available. It's reliant on tools from Japan, chemicals from Japan, tools from the US and the Netherlands. And so the reality is that the most cutting edge you can produce at scale in China is 3 or 4 generations behind what you can do in Taiwan. And I think we ought to assume that over the next at least 5 years and probably decade, that number will grow to 5, 6, 7 generations behind what you can produce in Taiwan. And so consider the doubling involved in each generation shift. That's a really vast gap that's in the process of being opened up.
Yeah, Angela, and I think it's a great question. I would just add that China was set to move up that scale, but then when SMIC was going to buy that EUV tool, the extreme ultraviolet lithography tool from ASML, but there was a control put in place in 2019 timeframe by the Wassenaar Agreement, which is a multilateral control regime that was really set up to do weapons of mass destruction and other military end use. And so the US government pushing that control basically has essentially prevented SMIC, which I think actually had a contract. And apparently every time Chinese officials go to the Netherlands, they ask, where is our EUV machine? But that's really a bottleneck because as Christopher noted, it's a monopoly. Only one country in the world produces that piece of equipment. It's incredibly complicated. It's probably the most complicated piece of equipment known to man. There's like 5,000 part suppliers to ASML for that piece of equipment. It's $250 million. I think the latest one might be even $400 million, the latest version of that. It's really incredibly hard to develop and maintain. It requires a huge sort of service trail, lots of 30 PhDs to come in and help you set it up. And so China can't really, for example, create that technology out of whole cloth. They can't steal the IP. They can't sort of invent a new system that's better than that, right? In the near term. Now, maybe over a 10-year period, they can come up with new advances or other ways to do this, but it's sort of a bottleneck that can't really be overcome. So that means China's SMIC is really frozen at around 14 nanometers. They've used their existing ultraviolet lithography equipment to get down to some level at 7 nanometers, but it's really tricky to do that and get commercial yields. And in fact, the Biden administration in part was reacting to that, the media reporting around SMIC getting to some level at 7 nanometers in terms of these export controls, because there was a feeling, because there's no companies in the U.S. that are producing at 7 nanometers, right? Intel is in the game there, but most of their production is not in the U.S. And so the issue of sort of moving up that technology scale is really tricky. And even if SMIC had that equipment, it would take them a number of years to master. And then, as I say, with these really high-end and expensive fabs, you need to have a big customer base over which to amortize the cost of that. And it's not clear that the economics even in China would work out without some change in the way the industry operates, and they would have to get a lot more clients and customers who would trust them and their technology. So China is sort of it's sort of screwed here because of this export control. And then the latest export controls set the bar at logic, which is what we're talking about here, at 16 and 14 nanometers. And the problem there is that the rest of the industry doesn't like that. And so it's possible, for example, that the tool makers in Japan and even ASML will not respect that control, because right now it's a unilateral US control. It's not been taken to Wassenaar yet. And so it's possible that the Chinese could, and I think that this will happen, will be able to continue to function and have fabs operate at the 14 nanometer level, because it's such a lucrative market for companies that they don't want to give that up. And so the result of this export control ban, for example, will be to basically freeze out US companies, and Japanese and ASML and other smaller tool makers could take over the market in China and keep those Chinese fabs running, but they're still going to be stuck somewhere between 14 and 10 nanometers or 7 nanometers, and they're not going to be able to go to the really advanced chips that are in your iPhone or in your 5G base station that really require that 5 nanometers or less, because of things like power consumption and just sort of the overall computing capacity that Chris mentioned that you need for certain applications. But China again will continue to produce at some of those legacy nodes, which are still very important. So it's not like they can't produce. The problem is if you cut off that advanced piece, the business model becomes tricky because those advanced parts are much more high margin. And so what you do is you generate a lot of revenue at lower margins with your legacy nodes, and then you generate at the newer nodes, you can generate a lot more revenue, which you then plow back into R&D. So if you take that away, the business models become a little problematic in China. And so that's what people are grappling with now, as the U.S. government has tried to freeze them at this node for logic and this nodes for memory too. So U.S. has dragged memory into this too, and that's been complicated because there are companies like SK Hynix and Samsung that are doing a significant amount of memory manufacturing in China, and so those facilities are now in jeopardy because they have no roadmap, for example, going forward.
Right, great insights. Thank you both. As I was reading Chris' book, I particularly focus on the second half because talk more about China. I care about what is the severe situation that China is facing right now. I increasingly become quite pessimistic about the outlook, and it looks like Chinese government have wasted a lot of resources on betting a lot on a lot of companies, and that doesn't seems to have gone nowhere. So, I mean, one quick question I have, because we have quite a number of questions from the audience already, is do you think the Chinese government is doing the right thing at the moment? I mean, is it pursuing the most optimal approach in order to address, these urgent demand from its industry and to deal with the geopolitics? I mean, or should China do something different? I mean, what are the missteps that the government have made? I mean, I welcome inputs from either of both of you.
I think that the economically optimal strategy for China would be to not do what it's doing and instead try to integrate more deeply to international supply chains. And if you look at what made it possible for first Japan, then South Korea, then Taiwan to win important shares of the semiconductor supply chain, they did so not primarily by focusing on self-sufficiency or independent development. They did so by integrating really deeply with the rest of the international supply chains. That's true whether you're looking at Japanese firms in the 60s, 70s, and 80s, or South Korea's emergence as a memory player in the 80s and 90s, or best example is TSMC, which on the one hand is the world's most important chip maker. On the other hand, as we've discussed, couldn't exist without tools and software and customers from around the world. And they've become successful because they've been more integrated than anyone, and they're the center of the ecosystem. The challenge that Chinese industry faces is that because of China's military buildup, the US has concluded it has no choice but to focus on computing power as key to what remains of its military edge in Asia. And so the US strategy is basically to say that the U.S. knows, the Pentagon knows it's going to be facing, China will produce more ships and more planes and more drones and more missiles than the U.S. will, especially if you focus on just assets in East Asia. And so the U.S. has got to try to, if it wants to keep its military edge, try to keep an edge in quality because it's going to lose out in quantity. And so the Pentagon believes that its primary differentiator in terms of quality of defense systems is computing power, signals processing, sensors, and that's all about chips. And so the U.S. strategy is basically to double down on its central role in the chip supply chain and cut off China from accessing these systems, with the goal of opening up the gap that I mentioned in computing capabilities over the next decade, and hoping that the U.S. will be able to apply advanced computing to its military systems, and that China will fail to do so in its computing systems, and thereby the U.S. hopes to keep what remains of its military edge. Now, given the current geopolitical landscape, I think that dynamic is really difficult to change. And so I think it would require a change in China's foreign policy and defense policy ultimately to open up a situation in which Chinese firms could integrate in the way that was necessary to produce another TSMC, for example.
Yeah, I totally agree with everything Chris said. I mean, the problem is the Chinese government has, very few choices here. I mean, as I noted earlier, the idea of sort of government subsidized and top-down development of the industry is just, at some level, doesn't compute because of this global division of labor and this sort of, the need for companies to be able to sort of specialize and focus on where they have comparative advantage. So for example, the Japanese government right now, they have a very well-planned semiconductor strategy. They lost a lot of they lost a manufacturing war, if you will. So they're not focusing on trying to outcompete TSMC. They're focusing on next generation packaging. And they want to do R&D with the US, and they want to be a player. They want their companies to be a player in sort of 3D packaging and the next chiplets, which is going to be the next sort of a way to extend Moore's law, for example. So that's what governments should be helping their companies to focus on niche areas in the industry where they have an advantage or where they can play. But the problem in China is that because of export controls and because of the geopolitics that Chris mentioned there, they're sort of stuck with trying to figure out how to subsidize and do every part of the supply chain, virtually every part of the supply chain. And again, that's just, you can't really do that. You don't have enough people, you don't have enough intellectual property. I mean, essentially right now, China is awash in capital for semiconductors. Not only do you have the National IC Fund, you have local government guidance funds, you have the STAR market in Shanghai. So the Chinese government has introduced sort of market mechanisms where promising Chinese semiconductor startups, for example, can go public and raise capital on domestic markets. But at the end of the day, you know, that's a problem because that approach is not going to produce a TSMC or a really big company that can compete, or even the niche players. And there will be some Chinese companies that will move up the chain, you know, both in terms of the design and production and things like manufacturing equipment. But the scope of U.S. export controls is really a huge impediment to this, because the latest package, for example, not only includes specific GPUs and manufacturing equipment, it includes the semiconductor input to semiconductor manufacturing equipment, right? So it's been sort of designed as this interlocking thing to really freeze China and really make it difficult, even if the government pours more money in, for those companies to innovate and develop and move up the chain, because they're cut off from a lot of key inputs. And so they have to develop almost the whole, you know, restart and start at zero and invent the whole thing from beginning, right? And there's just, you know, that we're talking about, you know, an impossible task, not because of the money, but because of the people, trained engineers, and also, you know, business managers. For example, one of the big things lacking in Chinese companies is just business managers who know how to run a business, a semiconductor business, and know how to make that work over time. And so that you can continue to you know, innovate and reinvest and have a client base. And that's really what's been lacking also. So China is in a really difficult position. So the government will double down, but there's no easy answers to any of this, right? They're not going to be able to just spend their way to you know, back into the game here, for example. So they're going to have to focus domestically and hope that they can still access some of these other technologies from non-US sources, like Japan and the Netherlands and other parts of the world that may not go along fully with the US policies and restrictions.
Right. I mean, these are great points. We are now a little bit out of time, and then we have 4 questions from the audience. Let me try to summarize the audience question in one big question for you guys. So most of the questions revolve around the consequences of these restrictions, and obviously vast majority were imposed from the US side. And do you think that those restrictions are really achieving the goals of the US government, or do they have some unintended consequences? I believe that Paul may have mentioned some of them in his earlier remarks. But generally speaking, I mean, are these tech embargo imposed on China right now, are they doing what they're intended to do, or are there any unintended consequences?
I think there will definitely be unintended consequences of the type that Paul mentioned. The companies will be harmed because sales will be lower than expected, things like that. I think those were expected unintended consequences, I guess I would say, from the perspective of the US government. I think I'm in agreement with Paul that the controls will work in terms of their intent of causing dramatic delays in China's ability to advance semiconductor production. So in that sense, they will work. I think it's pretty plausible they will work in their broader military goal of opening up a gap between the technologies available to the Chinese military versus technologies available to the US military over the next decade. That seems pretty plausible. I think the biggest unintended consequence that is hard to answer right now is what, if any way, the Chinese government will retaliate. In the past, the Chinese government has actually not retaliated against prior rounds of export controls. So when the US put Huawei, for example, on the entity list, China talked about retaliating and didn't do so. And so it'll be interesting, I think, to watch what China decides to do this time, whether it's rhetorical, whether it's economic, or whether it's something else in the diplomatic or military sphere as well. And I think the greatest risk of unintended consequence is if, in fact, China does retaliate, setting off a spiral of further either economic tension or political military tension. That's the risk that I see as most worrisome, even though if I had to guess, my guess would be that the Chinese government retaliation stays primarily in the rhetorical and maybe a bit in the economic sphere, judging by past responses to comparable export controls.
Yeah, totally agree. I mean, I think that every one of my clients is asking what's the Chinese response going to be, and there's a whole range of things there. And I think that the strength of that response will be really important to watch. I think that the unintended consequences are potentially really unraveling the overall global semiconductor industry in unexpected ways. So, for example, in 2020, when Huawei, in 2019, when Huawei was put on the entity list, and then later was the foreign direct product rule cut them off from Taiwan, that rippled through the industry and probably contributed a big chunk to the global semiconductor shortage, because it changed the way procurement managers thought about buying semiconductors. So they stockpiled a bunch of stuff and they upped their orders, and so that sort of rippled through the system. And one executive in the industry told me that they thought that the Huawei entity list caused the whole global semiconductor supply chain shortage. And I think that might be an exaggeration because there were other factors there. But that just shows you how the industry is very delicately, delicately sort of balanced between these global players. And so when you disrupt something over here, the effects can ripple through the system in unexpected ways. And I think here we're probably going to have this happen because as I said, the U.S. tool makers are probably going to have to pull back a lot from China. We're going to have some other players move in, but it will disrupt the cycle of innovation, because losing, for example, a big chunk of the China market for the U.S. tool makers will mean that their R&D budgets are impacted pretty heavily, right? And then that will ripple back into their ability to innovate, which some have argued is a national security concern for the US, because that could undercut their global leadership. Because the problem is, if you take China out of the equation, it's not clear that there's not enough of a market, for example, globally, to make up for the loss of a big chunk of the China market. And so maybe you can, as I said, the CHIPS Act, there'll be fabs built in the US, but probably that will not make up if those tool makers, for example, lose even more of the China market than they've already lost over time, as the Chinese government, subsidizes other players, the Japanese and other companies move in. So there's a lot of unexpected sort of second and third order collateral effects that we don't really know yet. But I think that you can probably bet they're going to be bad for innovation and bad for sort of the industry moving forward in the way it has before, with market-driven economies of scale, capital and people flowing into the most optimal kinds of positions, which again arguably produced Taiwan and TSMC the world being too dependent on them, but it also has allowed the innovation that has allowed us to cram this much computing power into this small space and put it on a missile, right? And so the question is, is that dynamic fundamentally changed, or does the industry sort of adapt and restructure its supply chains in a way that can help maintain that development and maintain Moore's law? And I'm not sure that I'm a little more pessimistic on that score, because I think the industry is very complicated, and messing with it too much may produce really bad outcomes.
Wonderful. I'm so glad that even within an hour, we were able to go so deep into this question. And I really want to thank Paul and Chris for joining the discussion today. And there's so much more in this book. So I really highly recommend you get a copy. it's quite cheap, I think, for a book of this size, and you got a lot out of it. I personally learned a great deal from today's discussion. And again, I want to thank the speakers and thank the audience for joining us. I'm sorry to those audience who raised questions. We are not able to go through all of them. But we hope that we have the opportunity to invite you guys back next time for a longer and more thorough discussion. So thank you all, and goodbye.
Thank you.